In this section, we're going to cover the key idea behind explaining motion, which is the concept of force. The concept of force is something that we invented to help explain motion, and what you're going to see going forward is that forces are going to be the main tool we're going to use to be able to help explain the motion of an object. Now you can see the definition of force here. It really just encapsulates the idea that a force is something that causes an object to accelerate. The symbol for the force is going to depend on the actual force. So in this table here, you can see several forces that we're going to see throughout this course. Friction, for example, is going to have the symbol lowercase f, but primarily most forces are going to have a symbol where you use the symbol capital F with a subscript to represent the type of force that's acting. Then the next force in the line here is called normal force, and students often have questions about that word normal, but normal is simply a mathematical term which means perpendicular. It means perpendicular in 3 dimensions, whereas perpendicular typically happens in 2 dimensions. And so when you see that term normal in your head, you can translate that as the perpendicular force. And it's the perpendicular force exerted by a surface, like a table, on an object that's resting on top of it, say a book. The next force is tension. And then we see weight. Weight is the force of gravity, and this one we're going to study in more detail later in this chapter. All forces have the units of newtons. Now, the important thing about forces is they are a concept, so they cannot be seen, just their effects. Although the forces can't be seen, forces always have agents. These are actual physical objects which cause the force. So one of the hardest parts about this course is figuring out which forces are acting on an object. And so because forces are concepts, they can seem a little bit mysterious, but if you always trace them back to an agent, then in that case, it will make it much more concrete and much more clear what forces are acting on an object. There are 2 types of forces. The first type is contact forces. These act between 2 objects that are touching. So in this case, it's quite easy to distinguish the agent because it should be touching your object. Long-range forces, these can act between objects which aren't touching. Fortunately, in this course, we're only going to see one long-range force, and that's the force of gravity. If you jump up off the earth, the force of gravity still pulls you back down, and so you do not have to be touching the earth for the force of gravity to be acting. Now that's different from all the other forces that we'll see. All the other forces are contact forces. So I have 2 tips here for you in terms of locating forces. As I said, understanding what forces act on an object is the key to analyzing its motion. And so to aid you in determining which forces act on an object, I will give you a series of tips. The first tip here is that the force of gravity is always acting. Never forget it. The other one is that because most forces, all the forces besides gravity, are contact forces, then if the agent is not touching the object, it is not acting on the object. And so I like to use the words, if it's not touching, it's not acting. So when you are trying to analyze which forces act on an object, the first thing you should do is write down gravity. The other thing you should do is see what else is touching the object that we are analyzing. Newton's 3 laws will be the key to analyzing the motion of our objects. And so let's go ahead and look at the first law. In this case, you can see the first law here. An object will travel in a straight line at a constant velocity unless an unbalanced force acts on it. Sometimes we call that unbalanced force a net force. And yes, the concepts are necessary for understanding motion, but there are also some key aspects of this law which are important for solving problems. So let me give you a little bit of context. Newton used ideas that dated back to Galileo to form this law. And when Galileo was working, most people thought that it was a natural law that all objects came to a stop. Why did they stop? Well, that's just the way it was. What Galileo proposed was a radical notion. He said that if an object stops, it's because something stopped it. And this was quite different. No longer was it a natural law that things stopped, there was a cause for it. And that was the key idea that Galileo was adding. And so what this meant then is that if no forces act, an object will continue its motion forever. And so Galileo used the term inertia, which referred to an object's resistance to change its motion, which meant that an object wanted to continue its motion forever, and it was only by causing it to alter its motion that it would do so. And so the first law can often be rephrased as the law of inertia, and you're probably familiar with this first statement of it. An object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. And this captures Galileo's notion that an object will continue its motion forever unless an outside force causes its motion to be disrupted. And so the key tip here is that if an object is moving to the right, that doesn't necessitate a force to the right. Oftentimes, students will add a force that doesn't exist because they see something moving to the right and they think, oh, it must have a force that way. But that's not the case. In free fall before, we saw an object being thrown upwards, and for a time it did travel upwards, but the only force acting on it was gravity, and gravity was pulling it downwards. And that's because the object thrown upward wanted to continue its motion, and it would do so for a time until gravity was able to stop it and bring it right back down to the earth.